Hi everyone, my name is Aiden Christian, and today I'll be presenting my research on how semantic search is transforming educational video retrieval and whether it can outperform traditional keyword search in technical learning environments. This research began from a simple observation I made while teaching Python programming. Many students clearly understood the problems that they were facing, but they did not know the exact technical terms and vocabulary needed to search for those solutions. For example, a student might ask, why does my code get slower when they add more loops, without realizing that the actual concept that they're looking for is called time complexity. Even when the correct explanation existed somewhere on an educational platform, somewhere on the internet, students often struggle to find it because they do not know the exact terminology required by the search system. That observation led me to ask an important question. What if an educational search system could understand meaning instead of just words? And more importantly, what would that mean for learning, accessibility, and educational equality? The problem that I focused on is called vocabulary mismatch problem. Research shows that approximately 94% of students use search engines as a part of their learning process. However, only about 26% are considered proficient at creating effective search queries. Researchers have also found that roughly 40% of irrelevant search results are caused by vocabulary mismatch. In simple terms, students often know what they want to learn, but they do not know the exact vocabulary needed to find it. A student might search, why does my code get slow when I add more loops? When they are really trying to find more information about algorithmic complexity and computational efficiency. That challenge is that the challenge is that traditional search systems expect users to already know the language of expertise. This creates a barrier for beginners because people who need educational support are often the people that have the least technical vocabulary. As a result, educational platforms unintentionally make it harder for beginner learners to access that knowledge. To understand why this problem exists, it's important to understand how keyword search actually works. Traditional keyword search systems retrieve information by matching exact words and phrases between a user's query and index documents. Methods such as the TF-IDF and BM25 analyze word frequency and lexical overlap to determine which results appear more relevant. These systems are fast, efficient, and highly effective when users already know the correct terminology. For example, if someone is searching binary search tree or big O notation, keyword search generally performs very well because there's a strong overlap between the query and the educational content. The problem appears when learners understand a concept but do not know the actual formal name. Keyword search recognizes vocabulary but does not understand the meaning. Two people can search the same question using different wordings, and keyword search may treat them as a completely unrelated search. Semantic search takes a fundamentally different approach. Instead of matching exact words, semantic search attempts to understand meaning. Using the transformer-based language models such as SentenceBERT, both queries and educational videos can be converted into numerical representations called embeddings. These embeddings allow systems to compare concepts rather than just vocabulary. For example, a learner might search, how do I make my program run faster? Even if the words algorithm optimization were never in the query, semantic search can recognize that the concepts are closely related and retrieve the correct educational content. This ability is especially important because people often think conceptually before they think more technically. Students typically understand an idea before they learn the actual formal meaning and terminology associated with it. Semantic search helps bridge that gap together. So, long before I conducted this study, I reviewed existing research on information retrieval, educational search systems, and natural language processing. The literature consistently revealed three important findings. First, vocabulary mismatch remains one of the largest barriers to effective educational research and searches. Second, transformer-based language models dramatically improve the ability of computers to understand context and meaning. Third, semantic retrieval systems consistently outperform traditional lexical retrieval systems for concept-driven queries. Researchers found that dense retrieval systems powered by the semantic embeddings significantly outperform traditional approaches such as the BM25 across multiple retrieval benchmarks. Educational researchers also repeatedly observed that students struggle to formulate effective search queries because they are still trying to learn the language of subject that they are studying. However, despite these findings, relatively few studies directly compared semantic and keyword retrieval specifically within technical educational video environments. That gap becomes the focus of my research. So the central question guiding this research was very simple to me. Does semantic search outperform keyword search for educational video retrieval in technical subjects? My hypothesis was that both systems would perform similarly when users search for exact technical terms, because strong vocabulary overlap existed already in those situations. However, I predicted that semantic search would significantly outperform keyword search when learners used natural language questions or conceptual phrasing. In other words, I expected semantic search to be particularly beneficial for beginners who understand concepts but do not yet know the formal vocabulary associated with them. So to test this hypothesis, I implemented two retrieval systems using the same educational video dataset. The dataset include publicly available content from the MIT OpenCourseWare and Khan Academy and cover topics such as computer science, algorithms, mathematics, and engineering, and data structures too. I then created 30 educational search queries divided into three categories. 12 were natural language questions, 10 were paraphrase conceptual expressions, and 8 were exact technical term queries. The semantic search system used sentence BERT embeddings and stored with PostgreSQL using the PG vector extension. This the keyword system served as a traditional lexical and retrieval benchmark and baseline for that. Because both systems operated on the same dataset, any differences in performance could attribute to the retrieval architecture itself rather than the differences in content. For the evaluation, I focused on something called the intent alignment. Instead of asking whether a retrieved result contains similar words to the query, I asked a more important question. Did the result actually answer what the learners wanted to know? For example, if someone searched, "Why does my code get slower when I add more loops?" I considered a result successful if it explained concepts such as time complexity and computational efficiency. A result about loop syntax would not be considered successful, even if it shared similar vocabulary. This approach allowed me to evaluate whether the system actually understood the learner's intent rather than simply just matching words. This slide contains the most important findings of the entire study. The natural language for the natural language queries, keyword search achieved approximately 40% intent alignment, while semantic search achieved approximately 85%. For paraphrase conceptual queries, keyword search achieved around 35% alignment, while semantic search achieved roughly 80%. For exact technical terms, both systems performed similarly, with keyword search achieving approximately 90% alignment and semantic search achieving approximately 92%. Overall, semantic search improved retrieval alignment from approximately 85% to from approximately 53% to approximately 85%. This represents a improvement of roughly 32% percentage points across the entire evaluation set. The results clearly suggest that semantic search retrieval is most valuable when learners understand the concept but do not yet know the vocabulary. The results revealed something far deeper than simply which search system performed better. They kind of revealed more about the learner itself and what they actually think. People generally think in concepts before they actually think about technical vocabulary. A beginner might understand the idea of a problem long before they actually learn the formal terminology used by experts. Keyword search assumes learners already know the language of expertise. Semantic search helps bridge that gap by focusing on meaning instead of the exact words. One of the most important conclusions from this research is that educational search systems are not uh, neutral technologies. The way information is received directly affects who can access knowledge and who cannot. The implications of this research extend far beyond educational video search. Today, semantic search is already influencing AI tutoring systems, recommendation engines, adaptive learning platforms, and educational assistants. In the future, semantic search could also support personalized learning environments, searchable lectures, multilingual educational systems, and AI tutors capable of understanding learner intent more efficiently and effectively. As artificial intelligence becomes increasingly integrated into education, the ability to understand what learners mean may become just as important as the educational content itself. Like all research studies, this project has limitations. The evaluation relied heavily on a small data set and qualitative assignment conducted by a single researcher. In addition, the study did not include expert annotated benchmarks or classroom implementation testing. Future work should involve larger data sets, learner, uh, learner, uh, ter- learner outcome studies, expert evaluators, and real-world classroom testing. Researchers should also investigate hybrid retrieval systems that combine the efficiency of keyword search with the computational flexibility of semantic retrieval. Despite these limitations, the findings provide strong evidence that semantic search has significant potential to improve educational accessibility. In conclusion, this research demonstrated that semantic search significantly improves educational retrieval for beginner learners, particularly when learners use natural language or conceptual phrasing instead of formal technical terminology. While keyword search remains effective while users already know the vocabulary of a field, educational systems are fundamentally designed for learners who are still developing that knowledge. Semantic retrieval helps bridge that gap by aligning search systems more closely with how humans naturally seek understanding. If there's one idea that I would like you to remember from this presentation, it is this. The ultimate measurement of how educational search systems is not whether it retrieves words correctly. It is whether learners who do not yet know what they want to search for can learn what they want to learn. Thank you so much, and let me know if you have any questions about this presentation. Thank you.